Good morning. I am Dr.R.Narmadha, Associate Professor, Department of Electronics and Communication Engineering, Sathyabama Institute of Science and Technology, Chennai. Today, I am going to explain about breadth first search strategy. What is search strategy? It's a path to select from the initial state to reach the goal state, picking the order of node expansion. It is evaluated along with the following dimensions: completeness. It provides a solution for a given input when there exists at least one solution from this input. Time complexity. Many number of nodes generated based on the complexity of the task. Space complexity. Maximum memory or storage space needed when conducting a search operation. The last one is optimality. Find a low path cost with best solution. There are two types of search strategies are available: informed search strategies and uninformed search strategies. Informed search strategies are based on heuristics algorithm. Heuristics, it is an approach to problem solving in which the objective is to produce a working solution within a reasonable time frame. Major types of informed search strategies are greedy best first, A star algorithm, memory bounded, and also generate and test, hill climbing, and problem reduction algorithm. There is no heuristics in uninformed search strategies. The types are breadth first search, depth first search, and it is expanded by depth limited search, iterative deepening depth first search, and uniform cost search, bidirectional search algorithm. Breadth first search is simply called by BFS algorithm. It is an unguided search or blind search worked by brute force algorithm. Brute force algorithm means it checks each and every single element along its way to get the solution. It searches level by level fashion. It is an algorithm where we first expand the root node and then expanding the successors. The process continues till all the successors are exhausted. It uses first in first out queue for achieving this functionality. In this graph, A1, B1 to B3, C1 to C6, D1, D2 up to D8, E1 and E2 are the nodes. L1, L2, L3, L4 and L5 are the levels. According to BFS algorithm, A is the parent node or the root node expanded first, and then it goes to the next level L2. All the neighbors of the node B1, B2, B3 are expanded, then it goes to the next level L3. All the neighbor nodes C1, C2, C3, C4, C5, C6 are expanded. Then it goes to the next level L4. All the neighbor nodes D1, D2, D3 up to D8 are expanded. Then it goes to the next level L5, completes E1 and E2. And this is the order of BFS algorithm. So, once the algorithm visits and marks the starting node, then it moves towards the nearest unvisited nodes and analyzes them. Once visited, all are marked. These iterations continue until all nodes of the graph have been successfully visited and marked. Queue operations for the BFS. There are two processes are there. DQ process. Each time to take out one node from the queue. NQ process means to add to the queue all of the new neighbors of node. And the traversing a graph, it uses breadth first search is the algorithm. Step 1, take a empty queue. Step 2, select a starting node and it is the root node and insert it into the queue. And the step 3 is, provided that the queue is not empty, extract the node from the queue and insert its child node into the queue. Step 4 is print the extracted node. In this graph, first extract the root node A and keep the child nodes of A, B1, B2, B3 in the queue. Next, dequeue the B1 and keep the child nodes B2, B3, C1, C2 in queue. C1 and C2 are child nodes of B1, and next one is dequeuing B2 and keep the child nodes of B3, C1, C2, C3, C4 in the queue. And the C3 and C4 are the child nodes of B2. Next, dequeuing B3 and keep the child nodes C1, C2, C3, C4, C5 and C6 in the queue. And the C5 and C6 are the child nodes of B3. And next, dequeuing C1 and keep the child nodes C2, C3, C4, C5, C6, D1 and D2 in the queue. D1 and D2 are the child nodes of C1. Repeat the same process until the queue is empty. Properties of BFS. It will have completeness, space complexity, very memory intensive. It needs to keep track of all the nodes in the search tree. The next one is time complexity. Time complexity is slow. It expands all the nodes in each level before moving on to the next level. There is no optimality unless step costs are constant. So, in practice, the memory requirements are typically worse than the time requirements. Applications of BFS algorithm. It is used to find the shortest path and garbage collection algorithms. Thank you.